Hello, everyone. Welcome and thank you for joining our webinar today. My name is Jasmine and I'm the Sales Development Representative at EnviroPod, and I'll be the host of this webinar. This webinar is about critical factors with retrofitting catch basins to trash trap at the source. Today's presenter is William Harris, who is Vice President of EnviroPod, Inc., a leading provider of stormwater treatment technologies and products installed throughout North America, New Zealand, and Australia. Mr. Harris has over 30 years of experience in the environmental industry and has successfully introduced a variety of new and innovative stormwater treatment technologies and products for use in private, public, and industrial sector markets throughout the USA and Canada. In addition, Mr. Harris has extensive knowledge of both proprietary and non-proprietary stormwater BMP technologies designed for municipal and private development applications. Mr. Harris is a graduate of San Francisco State University, and he holds a certification in environmental assessment and remediation from the University of California, Davis. Mr. Harris is also the former president of the Stormwater Equipment Manufacturers Association. So this presentation will take about 40 to 45 minutes, and we'll conduct a Q&A at the end of the presentation. If you have any questions during this webinar, please type them into the Q&A feature at the top, and I will read your questions to Mr. Harris, and he will answer them at the end of our presentation today. Okay, welcome, Will.
Oh, well, thank you, Jasmine. That was a great introduction, and welcome those out there and attending. Thank you very much for joining us for this presentation. I'll try to capture and keep your attention for the next 45 minutes or so. I'm showing you challenges that are faced with retrofitting catch basins to trap trash and give you some prime examples of projects that we've been engaged in, as well as giving you an overview on the technologies that are available out there. I'll quickly just briefly go through the overview of this presentation. A little introduction about EnviroPod, and move into what is trash, and this is what I call my trash talk portion of the presentation. We'll talk about sources of trash and trash leakage. Spend a little time on trash regulations and what regulations are currently out there about mitigating trash in conveyed and runoff. Then we'll get into the actual characteristics of the catch basins and the challenges behind retrofitting catch basins, and give you some real world examples that we've dealt with over the past 25, 26 years in being able to retrofit those catch basins to trap trash. And then we'll get into different technologies and different options that are out there in the product world, mostly all manufactured trash treatment devices, or MTDs as they're called. We'll go through those different categories of smaller types of systems. And then, of course, what's really important anytime you put a device in to capture trash, it has to be maintained just like your vacuum cleaner would be at home. It all requires maintenance. We'll go over maintenance regimens and what constitutes maintenance. And then I'll get into some separate trash capture projects from around the country that may be of interest to you. So a little bit about EnviroPod. EnviroPod is a California-based company, though we're part of a larger group called the Stormwater 360 Group, which is a specialist stormwater management green infrastructure technology company based out of Auckland, New Zealand. We believe in science and research as part of our ongoing efforts to improve water quality outcomes. The products and technologies we have developed at Stormwater 360 Group, as well as EnviroPod, all geared around addressing and mitigating gross pollutants and sediments and other types of pollutants concern that impact our waterways. And our mission is all about protecting our waterways. With that, to introduce you to two of the products that we manufacture here in the USA, as well as in Canada, is the LidaTrap, as well as a product called the EnviroBasin. We won't be focusing much on the EnviroBasin today, though it is a product that we have introduced in Canada and parts of the East Coast in the USA. It's a fully encapsulated catch basin, just like a standard catch basin, but in this case, it already has the built-in LidaTrap parts and components inside the catch basin to effectively turn that catch basin into, similarly to like a separator. So that's a technology that we launched last year, and it's been successfully being installed around the greater Ontario region. But for today's presentation, we're really going to focus on trash treatment control technologies for retrofitting existing catch basins, whereas the EnviroBasin is really something that's being used primarily at new development, residential, commercial projects around the country. LittleTrap is our brand that we've introduced into the USA. It's become very successful. We have some 50,000 LittleTrap devices that are currently installed in existing catch basins around the world, primarily USA, Canada, Australia, and New Zealand. That's after 27 years of installing this product, and it's still operating. The good news about the LittleTrap is extremely durable. We have some of the same LittleTrap devices that are installed in New Zealand that were introduced 27 years ago. That gets you some idea on durability. Trash talk. So this is where you get an opportunity if you're having lunch right now. I'm sorry if I spoiled it, but we're going to be looking at trash. And if we're looking at trash where we started back 25, 26 years ago, this is at the end of the LA River prior to going out into the ocean. This was a regular scene many, many years ago. Now it's not so much because the city of LA County has done a lot to help clean up by preventing trash from getting into the river. But again, this is why we're here and what the technology is all about in preventing these types of occurrences and seeing this accumulation of trash. It's quite visible. And this is a waterway. I won't mention where it is, but it is in the USA. The type of accumulation of trash that occur in our waterways. And this is where things happen now around the world. I think many of you in the audience may have heard of the Great Pacific Garbage Patch, but around the world, with all of our currents that are basically moving materials and moving things around the world, in the center, just where I'm located in California, about maybe 500 miles off the coast, you'll start running into the East Pacific gyro and the West Pacific gyro further on beyond that, where there is very large accumulations of trash and debris. And there's over 200 million tons of trash debris that's generated, reaching our waterways every year. This is a video. I'm not quite sure how this is showing on your screens as attendees, but if it's a little herky-jerky, I apologize. It's because the internet is a little bit slow sometimes. But this is a diver that actually was off the coast of Indonesia about 2 years ago. Kind of gives you an idea of when trash does get in the ocean, it doesn't all end up in the top floating. It can be in different suspended states, depending on the weight of the particular trash piece or plastic or whatever material it may be. Eventually, all this material does end up floating to the bottom. But mostly when you see it in the waterways over long periods of time, it's in a suspended state in the waterway, and it makes it very, very difficult at this stage to be able to clean it up. So this is why it's important when we're addressing trash and debris that we get it closer to this, we capture it closer to the source of where it's generated. And this is why I show this slide, is that it really all begins here, right at the catch basin, when we're talking about conveying trash from stormwater. So really, when we're focusing on trash and what is trash, I'm going to take a little sip of water. When we're focused on trash, trash comes in different types of pieces and materials, plastics, organics. It can come in different sizes. And for purposes of defining trash in this case, it can be in any form of either in a debris or sediment, or it could also, in terms of being floatables, it many times can get ingested in animals. And a lot of materials that come out of animals, we actually been part of studies with, these are actual pieces that have come out of turtles as well as fish. And this is why it's having an impact on our marine environment so often. And breaking that down in terms of what trash and plastic and gross pollution we're seeing, and when you are able to actually then count it and analyze it, gross pollutants consist mostly, of course, sediment 50 to 90% of gross pollutants are organic, of litter and debris. The biggest part of this, which causes major problems, of course, is 70-80% of trash and debris is inorganic materials such as plastic. So there's a lot of plastic that's conveyed and runoff that ends up in our waterways. 20% of that is floatable, and 80% in terms of the actual mass load production that comes out of urban areas is 320 pounds per acre. That's a very large amount of material coming just out of urban areas. So we have a good idea, and I think you all do in the audience, of where trash is essentially sourced from and where it comes from, but it's a variety of different locations, whether it's in a local business area or many times down from food sources or restaurants, bars, of course. We've had our litter trap devices placed in these hot spots where they're accumulated around larger, more high density urban areas that tend to capture more of this type of debris. All of that, if you don't have some type of trapping system, can end up in the local creek, waterway, ocean, wherever it might be. There's still a lot of ongoing illegal dumping going on, but not as critical as just non-point source pollution that is generated from all these various sources that come from residential, commercial, or from industrial applications. Stormwater is the biggest pathway for plastic leakage overall. In terms of the amount of volume of stormwater that conveys trash to stormwater loads, it's 300 times greater than wastewater to load pollution into a bay. So if that gives it essentially the essential importance of why we need to consider addressing this issue by retrofitting catch basins. It's really important. Then, of course, with macro and microplastic leakage in the production of plastics, 3% of annual plastic production ends up in stormwater or in the waterway. Out of that, 84% is essentially a visible microplastic or large particles that you can actually see, and 16% are microplastics, things we really can't see unless it's even under a microscope. From there, for those of you maybe are pretty young for this, but there was an old movie that came out many years ago called The Graduate. And this is around my time when I'm aging myself now, but one of the major things I learned from the lesson of this particular movie was a gentleman talking to the graduate, explaining to what the future was, and it said the future was the word plastics. Well, we now know a lot more about plastics, and we have a tremendous amount of plastics in our environment and throughout the world. And it's become a serious problem as far as being able to contain those plastics from reaching our waterways. And we're learning more about the effects of plastics over time. This is not to give a barb against the plastic industry. And actually, there's parts of our product that are made up of plastic. And we appreciate what the plastic industry has done. But at the same time, even the chemical industry of America understands the issue behind the conveyance of raw plastic and plastic materials that are reaching our oceans. In terms of regulation, we do have around the United States a number of different locations and regions and states that have either enacted regulation or have adopted a TMDL type of regulation to prevent trash and debris from getting into waterways. California, being the most notable at this point, has actually established trash regulations and set up a statewide strategy for the prevention of trash and debris conveyed in waterways. We'll get into that a little bit more, but we're also seeing quite a bit of activity going on in island states like Hawaii, which has become a major issue to prevent trash from being conveyed into their waterways. Down in Texas, where we're seeing quite a bit of activity around the Gulf region to prevent plastic and other trash and debris, is now becoming more and more of an issue, and industries are actually taking up the mantle of applying trash capture technologies in those regions. A lot has been said about New Orleans, and one of the things that have been going on in city of New Orleans is that they have been retrofitting their catch basins for some time now, ever since Hurricane Katrina hit New Orleans about 10 years ago, or more than that now. At that time, the pump systems all shut down, a lot of it because the pumps were clogged from trash and debris. So there has been an ongoing program in New Orleans, which I really take my hat off to them for being able to retrofit their catch basins, prevent trash and debris from getting into their storm drains. In Florida, we're seeing a myriad of activity going on from Miami all the way up the coastline in Miami-Dade County, all the way up to the eastern seaboard, and of course, the Anacostia River in Washington, D.C. has now enacted a trash and debris TMDL for a number of years, and that's now addressing that issue over there. They're talking about California. California adopted a statewide trash capture law or regulation back about 7 years ago or 6 years ago. This requires all states, all cities and counties, municipalities to adapt mitigating trash from getting into local waterways. And the state, under the state water board's management, has defined trash as any particle size that's 5 millimeter or larger, essentially the size of a small cigarette butt. And they also have defined what would be the flow rate or the defined volume of water that needs to be treated to capture that trash, meaning that as stormwater conveys trash and debris down a storm drain or down a street or a curb line, it's up to the cities to be able to mitigate or capture the first 1 year in a 1 hour storm event, which is a pretty significant load of water in capturing that first 1 year, 1 hour storm. Anything beyond that storm event is considered to be a higher peak flow and can go into bypass. So all trash and debris mitigation in any type of plant or activity of putting in a device has to be able to mitigate the first 1 year in a 1 hour storm. So even our products have to be designed in such a way to capture that type of event and then allow the peak flows to bypass over. The other thing the state did, which was really smart, was to establish a certification program for any type of device that is going to be placed inside a catch basin or downstream at the end of the pipe must be certified utilizing a testing protocol as well as provide information on durability and hydraulics to be able to pacify and provide the state the ability to certify that product, and that the state will take on the liability of saying that product is certified so that the cities don't have to go about individually testing these products. Each manufacturer is responsible for submitting an application that addresses the issues around hydraulics, bypass, as well as being able to be maintained and provide maintenance and accessibility to catch basins. All this goes into a certification review process. It so happens our products are also certified in California, which is the first time that an actual state has attempted to provide a actual testing and certification protocol. This is actually a copy of the certification for our LittaTrap in the state of California, which we provided the necessary information, the application process, which lists our products as well as other different systems and devices and technologies that have been reviewed and certified by the state of California to be able to mitigate trash at the designed flow rates and regimens that they require. The results so far, after 10 years of regulation, not only from the state by various cities, have really brought in some great benefits and results. In the Los Angeles region right now, the actual capture has provided 6 million pounds of trash per year with 17,000 installed full capture devices. That's really amazing. Bayonet Creek, which is actually the photograph I showed you originally during my trash talk, that was at the end of the LA River, showing actual capture over 1 million pounds of trash per year in 2,500 full capture systems. And they have an actual end of pipe type collection system that's been incorporated as well. San Francisco Bay, which of course is a very large urban area, and you have some 8 million residences around the San Francisco Bay region, high density, high urban areas. 90% of local cities are now in compliance with placing trash trapping systems now around the San Francisco Bay. The goal is that they intend to have 80% of all trash reduction done by the year 2030, which is similar to the goals for many municipalities around California at this point. So California is on a good path right now to get and address and mitigate their trash debris, though there's still tremendous challenges for cities to be able to come up with the funding. For those of you who represent a city in the audience, my heart is with you, understanding that meeting this goal is extremely difficult, and many cities are just now beginning to address this issue and trying to obtain funding after obviously coming out of COVID period, where there's not a lot of funding available to be able to apply these types of trash trapping technologies. There is good news on the horizon on a national protocol for trapping trash. I don't know if any of you have heard of the STEP program, but it's a program that was established back a number of years ago, and is managed by the National Municipal Stormwater Alliance. Some of the audience may be part of a city or organization that's a member of the National Municipal Stormwater Alliance. This is essentially a way for cities and municipalities and states and other agencies to be able to evaluate those types of technologies that have gone through an actual testing protocol for trapping trash and be able to effectively operate inside a catch basin or outside a catch basin. And as a manufacturer, we really welcome this opportunity to see that there is now a actual national testing protocol just being released recently, which was actually developed by ASTM and then adopted for use by the National Municipal Stormwater Alliance. So in the next couple of years, we're going to be seeing technologies like ours that are going to be applying for the STEP certification. With a STEP certified device, essentially you will have assurances that that device will be able to claim what it says it can do in terms of mitigating trash. So I really invite all of you in the audience to visit the National Stormwater Alliance website and check out their STEP evaluation program. And for those cities who are in the audience representing, please, if you're not participating in NMSA now, you might want to join and consider joining. It's a worthy organization in terms of keeping up with stormwater treatment technologies as well as testing protocols. So let's get into the nuts and bolts about retrofitting catch basins and the critical factors behind that. Obviously, with catch basins, there's no one size. They're all come in different sizes. We pretty much have dealt with them all. The characteristics of catch basins vary greatly. There's no two the same. There can be dry catch basins like there are many in California, and there's also sump catch basins which contain water at the bottom of those catch basins. All catch basins, one have definitely for sure that all of them are alike, is that they all have a short term of concentration, meaning that the amount of water flowing into the system is going to flow out rather quickly. There's not a lot of detention time in a catch basin. The whole purpose of a catch basin in the first place was developed so that water could be able to be conveyed off a roadway. So you did not have flooding. By introducing something inside a catch basin or something downstream at the end of the pipe that may retard that flow or detain that flow, that becomes some concerns. But the primary fundamental operation of any catch basin is to convey water off a roadway or a parkway or a walkway, wherever it may be, so we don't end up with a flooded area. In terms of just the most common type of catch basins that are out there that we see are the manhole grate inlet types, where you have a grate on the top and you either have a round or square or rectangular type system. These are examples of litter traps that are inside those types of catch basins. And of course, then we look at more the municipal type catch basins, which are curb entry type catch basins, as well as combined curb. We call the combined curb grate inlet on the right, where you've got both a grate and you have a curb opening on the side, and water's conveyed either way, depending on what the flows may be ascending into that particular unit. And those challenges are, we've seen, we have placement of litter traps in 50,000 catch basins. These are some examples of the more, let's say, unusual catch basins we've seen out there. in the cases on the far upper right, the original storm drain and catch basin was placed in the ground, was placed in before there was an actual road put in, and then a separate contractor came in and then placed the frame and grate, not exactly over the top of the opening. Those are challenges to be able to fit something inside that type of catch basin. Also on the right, we've seen rotated catch basins where again we have a catch basin opening that's not exactly aligned to the actual square frame and grate of the grate itself. That makes it rather challenging. And looking at all the different technologies that are out there, there aren't that many that can be able to be placed in these types of situations. So those are all big factors for us as manufacturers, and just passing that along to you for those of you who are managing these types of assets that are out there. Other challenges we have at facilities and other plants are channel drains coming in at the top, or pipes, inlet pipes. That makes it a little more interesting in terms of being able to place either a filter inside that catch basin of some kind or a device. And then, of course, we have round to square, square to round. We have inlets, all sorts of different interesting features with catch basins. And these is a prime example of where we're having flows from two sides in a parking lot coming into one catch basin. How do we develop and design a system that can be able to mitigate flows and trap trash and something like this? So we face this all the time as manufacturers, and we have to be able to be flexible and be creative and be able to clear those flows without creating problems for the owner of that facility or that asset as well. Here's a real challenge, and that is that it's kind of difficult to get any kind of a inlet filter or any kind of technology inside a catch basin if you have no access. So this is something normally when we have seen this very often and say, hey, how can you get a filter inside of this? And I have to tell most people, most say, well, we really can't, because you'd never be able to maintain it. So again, these are real challenges that we see all over the place. In managing trash and runoff, there's a lot of different options that folks have out there. One, you can develop source control, and that is basically what like California did, or several other states, was ban the plastic bag. Yeah, that works to some extent. It hasn't been that greatly successful in California. I'm not just offering my opinion. This is what has been reported by many of the organizations that are out there. But source control can be effective if it's properly managed and you have organizations to support it. Then, of course, there's that source controls, catch basin BMPs, which we're going to dive into in a moment. And of course, then you can incorporate inline or offline type high capacity screening at the end of the pipe. Then what has been ongoing for many years now by many nonprofit organizations are the good old beach cleanups and going out and being able to clean up beaches. I volunteer myself to go out for ocean beach cleanups quite often. And these are occurring now more often than they were, let's say, 10 years ago. And, you know, kudos to those organizations that are supporting those efforts as well. What's really important, I think, for those who are representing municipalities or that are actual end users or industrial permittees that are in the audience here today, instead of just looking at this as a large, problem that you've got, let's say 200 catch basins or 1,000 catch basins at all these different locations, if you are going to start to look at seriously placing devices in catch basins or at the end of the pipe, you really need to identify the hotspots. That's where it all begins. We've, as an organization, we have helped cities as well as other agencies in helping them address and identify where trash hotspots are. That's where things really can make a difference and be the most effective, instead of just placing devices or one big end of pipe system where you may not have a lot of trash at certain spots, but you do have at others. That also then defines what eventually is going to be your routine management and maintenance of those particular drainage areas. So we can break down manufactured trash capture devices or manufactured treatment devices, MTDs, into really two different categories. Small at-source BMP devices, such as what we manufacture with a lid trap. These are broken down and sub-breakdown to curb entry type screens, connector pipe screens, catch basin inlet filters, We're going to dive into this more in a second. But then you have another option for larger end-of-pipe type devices. These are the large end-of-pipe and box systems that typically are at the end of the pipe. Let's say you have 100 catch basins all draining into one individual large pipeline that all drain into an area before it gets into a waterway. These are where hydrodynamic separators or baffle box trash separators, I've worked with those in my past, and they can be extremely effective and be able to remove trash. At the same time, there's also, you have to weigh the advantages and disadvantages of what it's going to cost to purchase them, because they're not cheap, they're extremely expensive, and they're also expensive to maintain. But they're there for larger accumulations of trash at the end of the pipe. Then, of course, on the lower right-hand side where you see trash nets, those have been applied now effectively over the last 10 years. Number of locations, again, like anything else, there's a certain cost-benefit analysis that needs to be applied whenever you're looking at using end-of-pipe systems. We're going to look more at the small at-source BMP devices and what options you really have there in terms of an at-source catch basin insert. Take a little sip of water for a second here. So for at-source catch basin devices are really designed to be retrofitted, inserted into new or existing catch basins. They're really there to enhance the water quality benefit any standard catch basin design. They don't require any early construction. Manufactured at-source catch basins typically come in a kit or in a manner that can be easily installed. Overall, they're low capital costs. But like anything else, they require ongoing maintenance, and we'll explain that a little bit further in the presentation. These are some examples of small at-source BMP devices. We'll dive into those categories, but before we do that, these are some of the risks when you start applying any type of at-source inlet filter device, and that can be failure. These are examples of failures that we have seen, and these are actually right off the internet, showing failures of inlet filter devices that have either fallen apart or don't quite have the durability to last long periods of time. And of course, it may not be the case of the manufacturer being the problem. It may be the fact that the device was either never maintained, or it could have been possible from a fire that took place and or an accident. There have been cars that have fallen into catch basins, that I do know, and have created problems. So that doesn't necessarily mean a failure on the product, but you're always having a potential for a risk for a flood if you're not appropriately vetting the manufacturer device and really checking in terms of the durability. So, and it's also important for manufacturers recognize last thing we want to get is a phone call at midnight from a customer who owns a strip mall and says, hey, your product just flooded my street because it backed up and got clogged and had no way for water to get out of it. We have to be able to be cognizant of that problem and how to address that problem with properly designing our technology for that client's needs in terms of bypass operation. So another element to this is really, when looking at smaller type systems, is really how much storage can that device or that system contain, and how much time will it take to accumulate, as well as what are its treatable flow rates. If we're really trying to mitigate trash and debris, which is we're trying to capture particle sizes, they're fairly large overall. Are we designing the system, the screen or the bag, whatever it might be, so water can flow through properly, and we know what those flow rates are? That's something really important we need to know to pass on to engineers and to clients, as well as what is the actual bypass capability of that product. So over time, like anything else I mentioned earlier, a storage device or a stormwater treatment system is like having a vacuum cleaner at home. And you need to know what the size of that capacity is for that bag and how often it's going to fill up. And that's going to then become your maintenance regimen around that bag. We'll mention that. We'll go into that a little bit further. I don't know how many of you really look at technologies closely, but obviously being in the business and having worked with a lot of different technologies over many years, we don't like to make claims unless we can back it up with third-party performance data. That doesn't mean that what Will Harris says what it can do is is the actual fact. I have to be able to back that up with evidence. And that evidence has to come from independent third-party hydraulic testing. Now, as a manufacturer, we do provide third-party performance and hydraulic testing to assure whatever claim we make on whatever pollutant we're removing can be backed up from that third-party claim and be able to back up what the product can do hydraulically, both in terms of design flows and the design of the peak flow bypass. That is really critical. So this is just an example of our litter trap testing data. We have a very large ream of data. It's yours welcome to be able to review our technology data. You can also download copies of all of our data as well as other technology data by going to the California State Water Board website. All of us that out there that got a certification had to apply with that application. In that application, you will find actual independent data for the actual devices themselves. Talking about the technologies, let's focus on trash screens for a moment. I've taken 3 examples of different types of screens. You have fixed screens that place right along the curb line, and then you have similarly what we call an ARS screen. We're going to break down the ARS screen in just a moment. The fixed screen and ARS screens are not assured to capture 100% of all trash and debris. Essentially, they're designed to be able to prevent trash from getting into the catch basin in the first place. But if you don't have adequate street sweeping to support it, it's not going to be very much of a technology or very good technology for you to be able to be effective. Connector pipe screens, we'll get into that as well. Connector pipe screens have been used for about 20 years now in a variety of areas around the country, mainly in the Southern California region. Very popular here. Give you an example of the trash for the curb line ARS screen. ARS stands for automatic retractable screens. They're designed to be a first line of defense so that when water does come in and it's conveying pollutants along the curb line, they'll prevent that trash from getting into the catch basin. They're also designed to open up during peak flow events. So whatever trash you had accumulated, if you didn't have a street sweeper come by and pick it up, it's all going to end up going into the catch basin. So there you've lost the point without having something else inside that catch basin to capture the debris. There are definitely a routine street sweeping program that has to be engaged. Depending on how much pollutants is accumulated along that roadway, you're going to have a weekly or a monthly type of street sweeping regimen. Of course, you're hoping that before there's a big storm event occur, that street sweeping would occur. Otherwise, it may not prevent that trash from getting into that catch basin. There is a durability question about many of these types of devices. They are potential for high maintenance and repair costs. They are subject to breakage. But that's something that you need to consider when you're looking at these devices. There are different manufacturers out there that do manufacture these, and some are better than others. Cost range is normally in the $500 to $2,500 range. And again, low to medium installation cost, meaning 2 people can put these in typically anywhere from an hour to 3 hours, depending on the actual length of the opening. So it's not a significant installation cost for these. And again, without routine maintenance, this is really not going to be a very effective device for use for trapping trash. Let's talk about connector pipe screens. Having been engaged with the development of connector pipe screen previously, it's a pretty effective technology overall, other than the fact it will clog. It's subject to clogging very easily because of direct screening. Essentially the way this is designed, it's basically placed over the outlet pipe. And depending on the size of the outlet pipe, that is then designed where your screen would be covered. Has to be able to have a bypass at the top for water to always be able to get out. And one major advantage that a lot of cities have found using connector pipe screens is that it can contain and store the trash within the catch basin. So here you have a very, very large storage containment, being able to accumulate that trash over time. The problem again is that if you have a large accumulation of trash, it can tend to short circuit the amount of flow. So if another storm event comes in, brings a lot more trash in when the catch basin is filled, you're going to have a lot of trash going out through that bypass opening, especially floatables. So definitely subject to high clogging and screen occlusion. There have been failures of this device around the country, no doubt. But again, I always like to tell people it's a relatively low-cost solution. And as long as you have a high maintenance visibility and you have folks that are out there watching it, then it could become very effective for you. So that gives you some idea on that. The operation of it's very simple. Water flows in through the curb opening, rises, passes through the screen, and prevents the trash from going out, and then it has the internal high flow bypass opening there. Catch basin filters, which is the world I live in mostly now, has a proven technology. It's actually been the first stormwater treatment technology, MTD, that was introduced back in the 1990s when stormwater pollution was becoming an issue back in those days. It's designed for placement beneath a catch basin opening, and they can be equipped with various types of options for mitigating a variety of different pollutants of concern, and not necessarily trash. You can design devices to capture oils and greases by adding an absorbent or other smaller particles like sediment. So there is a lot of modulation and flexibility with these kind of products that are out there. As far as being a maintenance, it can be anywhere between 2 to 3 times a year on average, and that can be an issue for some cities. So with that in mind, there are manufacturers like ourselves that can offer larger storage containment bags inside these systems, or filters, if you will. And the cost ranges, obviously, is about $350 to $2,500, depending on the type and size of catch basin there are. But it's essentially still considered to be a low to medium installation cost with routine maintenance that goes on. There's a lot of different manufactured catch basin and filter device manufacturers out there. You can find them on the internet. Some of them are more common brands like ours, as well as others that are out there, and they either come in stainless steel materials or they could be an HDPE, fiberglass. There's a series of questions at the end of this presentation, which you're going to receive once you get a copy of this presentation, that you can ask manufacturers to provide you as far as materials, as well as the hydraulics of those systems as well. Give you an idea how this is installed inside a catch basin. This is a project we did with the city of Colton back in 2021. This was a retrofit of 10 catch basins, all of them curb inlets, and being approximately 7 feet long. So those of you who have never been engaged with installation of catch basin filters, it's pretty dirty, mucky work. But the first thing that needs to be done is to clean the catch basin. And then when utilizing the crew to climb into the catch basin, obviously it is a confined space entry requirement, you need to place the actual equipment inside below the throat opening. And then from there, once the equipment and the brackets are put in place, that's when you can begin to start to place the filters in. We never want to see these products impede any flow. So it's important that the design of the system is made so that it will capture that first flush, and then anything that's going to be flowing beyond the first flush or that 1 year, 1 hour storm, whatever the design flow may be for your region, water's going to be able to pass over the top of the system or through the internal bypass of the device itself. So this took this crew approximately 30 to 45 minutes to install the units after they had cleaned the vault. This has been operating now for the last couple of years in Colton successfully. They are maintaining the devices. There's been no phone calls or actually any kind of replacements, but obviously over time and the durability of the product comes into play. If they're not maintaining it, the product still needs to be able to withhold and stand up over time and be able to survive peak flows. So maintenance is a major issue for any type of insertable device. And it's important that there be some options for you that own these assets to either maintain them by hand or Vector truck and be able to have access. Access is probably the biggest thing that we deal with all the time, so that staff and your team can be able to get inside that catch basin, or be able to maintain it at the surface easily. What many cities are doing now is really basically going to more as a street, being able to maintain them from the street level, not have to climb into those catch basins. And another issue that needs to come into play is what are the replacement costs, if any, to replace parts and components that may be broken. So all of this comes into play when you are looking at any kind of device that is inside a catch basin. We developed a design of an inlet filter for cities as well as for clients called the EMMA design, the Easy Manhole Maintenance Access model, which essentially places the litter trap basket underneath a manhole so that anyone be able to maintain a litter trap at the surface and you never actually have to climb into the catch basin to maintain it. Though if you did need to get access, you could simply remove the basket that's under the manhole and then be able to get in if you need to. So this is built with a trough piece that fits across the throat opening of the catch basin. And then from there, the basket is placed wherever that manhole location may be and at the back end. Once the actual piece and this conveyance is all set up with the troughs, now it's ready to go into operation and give you a simulated rainfall event for how that occurs. During a rainfall event, in the initial portions of rainfall, it'll convey trash and debris to the actual trough. The trough conveys it to the actual basket, and water is able to get out and capture all that trash and accumulate over time. Then, of course, during a peak flow, when the water goes much higher, I can simply just go over the top of the trough and continue out. So that way, there's no flows that are being impeded. Here's the easy part, and that is the maintenance. And that is a matter of just lifting the manhole. You can use a Vector truck, or you can be able to lift it up by hand and wash or clean off the actual trap itself and then put it back in place. These are the kind of designs and options that we offer, and I'm sure there are others out there that offer similarly as well. I'm going to move forward here pretty quickly now because I'm coming to the end of the presentation and just get two slides in. And that is example projects we've done with cities around the country. City of San Marcos, Texas, we just finished doing a major install with them with 20 of our EMMA design inlet filters. They're primarily designing this around mitigating trash in their downtown area where they have a riverfront and it drains right into the San Marcos River. And they're trying to prevent trash and debris from getting into their roadways. This so far has worked very successfully for them. Their maintenance crews simply just go around the city whenever they do need to maintain them and get access and just be able to vacuum out the debris and wash down on the trough that debris into the basket, and there you go. We've done quite a bit of work up in Canada at this point for those joining us from Canada. City of Barrie is a prime example. They're using some 90 to 100 litter traps now in their downtown area for trapping trash, primarily in those high-density areas near restaurants, bars, and other locations that tend to generate a lot of trash. And that's been working very successfully to protect Lake Simcoe. And then we work with industrial applicants and chemical industry within their Operation Clean Sleep program. We've actually participated in studies showing that plastic industry or plastic manufacturers that generate a tremendous amount of plastic and raw plastic, one of the major concerns is that they're reaching waterways. And we were involved with a study with the University of Toronto, as well as the Chemical Industry Association of Canada, to be able to really quantify what the plastic and debris was getting into those storm drains. And so after that one-year study, came out to quite a bit of capturing of pellets in these systems. We've now expanded this program all the way down to Texas, as well as into Mississippi and Florida, where there are industrial manufacturers down there and that need to mitigate plastics and other debris from reaching the Gulf. And so far, that has been worked out quite well for them. So here's the question I want to be able to provide to you that you need to ask manufacturers like us. This is something that will be in your in the handout when you're able to be able to download this, or you can see it from our website. But I invite those of you who are there that are interested in utilizing catch basin sort of devices or screening devices, these are the actual questions you should all ask and be able to be assured of some information that what you're buying is basically backed up by appropriate information. And with that in mind, I'm going to go to questions. So I'm going to turn it back over to you right now, Jasmine, and see what we got.
Thank you, Will. So now we're going to start our Q&A, and if you have any questions, please add it to the Q&A section. Will, there are a couple of questions. Are there any illustrated trash capture devices that include the vector control components?
Yes, there are. Not in this presentation, but I welcome anyone who wants to see illustrations of vector control, which again, for those of you who are not from California, we in California has a requirement that it applies to manufacturer devices that they must allow for having a vector opening for drop inlet or drop into catch basins, so that health department inspectors can come in and inspect for mosquito growth in the floor of a catch basin. These are vector control access is very important to the health department. And one of the problems that has been in the past for having a catch basin filter in the way of viewing a catch basin is that there's no way for that inspector to know if there's any live mosquito larvae. That requirement doesn't apply anywhere else except in California. But for those of you in California and want to view vector control access photos, please reach out to me at my email address here, or just send me an email or visit our website. You can also see examples of vector control access elements photos on our website as well.
Next question is, which type of basin will you recommend for urban areas, for example, high trash and pollutant loads that are subject to high levels of runoff? For example, significant storm events likely needing high levels of maintenance and are generally under relatively flat terrain. For example, very low relief within a 5% slope.
Okay. Well, again, as the question is, what kind of catch basin or catch basin filter?
I'm assuming
device.
which type of device.
Okay. Well, again, it all depends. I guess I'm sounding more like an engineer now. It all depends on the actual size of that catch basin and what the depth of that catch basin may be. It could be that an inlet filter works just fine for that area. And in most cases, we've placed inlet filters, our products, in high density areas where you're getting a tremendous amount of trash coming in, but they have a routine regimen maintenance program for that area. It may be a screen. A simple screen may be just fine. You may be incorporating a screen, maybe a front end screen with a filter with those things. If it's a very, very large catch basin, there's a couple of different options to be able to provide. If it's a sump catch basin, that also comes into play as well. So I think it really comes down to what is the type of catch basin, what's the size of that catch basin, and be able to then make a recommendation of what would be the best technology for that system.
Next question is, do you have any cost for labor effort estimates for maintenance in different sites?
Well, typically it always takes two people to maintain any type of system, whether it's, and we're talking about for smaller type screens or inlet filter devices, MTDs, and safety factors also comes in first. The time for two people to maintain on average for like an inlet filter could be anywhere from 5 minutes to 15 minutes with a Vactor truck or even by hand. It's really very simple. It's just either lift, tip, and replace the basket, or in terms of using a Vactor truck, just putting the hose into the actual trap itself, back into content out, lift the actual basket out to get access to the sump or to the floor of the catch basin. That can be a 15 or 20 minute operation. Now, obviously, getting to the catch basin and egress and moving on is not added on to that, but typically doesn't take much time at all to maintain smaller inlet filters. And what we've worked with our clients is that usually what a lot of customers do is they will start out with going about maintaining them after major storm events, or on average twice a year, once in the spring and once in the fall. certain drainage areas may be accumulating more trash and debris. You may have to maintain those drainage areas more often, whereas there might be drainage areas where you're not generating much trash and debris at all. Those might be once a year to once every 2 years we have to go out and maintain them. So it's important that you find out after the first 6 months of where your real maintenance, intensive maintenance is going to be. And you only find that out after a time.
Do we have cost estimates for that?
They can range. With 2 people, it could be anywhere from $50 to anywhere to $500 to maintain a filter, depending on where it may be. So yeah, could be in that range.
And do we have any type of guidance that we provide to municipalities about long-term cost for ownership?
Yes, we do. And again, it depends on the project and the location. We do. We can provide that information. We do that. I can't speak for all manufacturers on that one.
All right, so I think that those are all the questions that we have. So thank you for joining us for our webinar, and we're going to be emailing a recording of our webinar next week. Feel free to reach out to us by email if you have any other questions or would like to know more. Our website is right there on the screen. Actually, our website is EnviroPod.com, and our toll-free number is there on the screen. And feel free to reach out for further questions or projects in mind, and we'll be happy to assist.
Great. Thank you for coming. Really appreciate it.